our next speaker here in this room has a challenge. And that challenge is he's speaking on something I don't know anything about, and he's got to make me understand it. So hopefully, if he can get to me, I'm sure he's going to be able to get to you. So everybody give a warm welcome to our next speaker, Earle Philhower from KIOXIA, right? And he's going to talk about enabling software-defined flash storage for the cloud. Welcome him to the stage, please.
Hi there, and thank you all for spending your afternoon, a little bit of it with me. And today I would like to talk to you about enabling software-defined flash storage for the cloud, and a unique technology that we're designing here at KIOXIA that can have real impact on your cloud operations, on the way you deploy flash. So here's our agenda. It's very brief here, and the key message is this is brief. This is going to be telling you the high-level view, the 10,000-meter view. We have a website, we have a booth, C02, where you can come get more information either in person or online to get into here. So let's begin. But again, before we begin, our mission here at KIOXIA, we've been around a long time, 35 years. We invented flash memory way back when. I think I was 10 years old at the time. It was really neat. And even today, we're focused on uplifting the world with memory. What that means is getting memory technologies out to people like you, people that are doing wonderful things with it, and helping provide a better customer service, better designs, better environment for everyone. Pushing the boundaries of flash. So at KIOXIA, we're a major manufacturer. We talk to a lot of service providers. We talk to a lot of hyperscale customers, and they come to us with congratulations, but they also come to us with some of the challenges that they're facing when they try to take the flash that we make or that other people make and put it in their servers and get the best value out of it. And I've tried to distill those down into 4 major categories of challenge that are happening now in cloud providers with flash. We have tenant isolation, basically keeping one workload from interfering with another workload. I hear a lot of concerns about latency control, making sure that an application gets the right sort of latency profile, and making sure that that application's latency profile and another one's, make sure that they both match. Data placement. Here, we're talking about maximizing flash performance, maximizing flash life, getting the most value out of the flash that you've installed inside your servers. And finally, migrating between different flash technologies. It's always a challenge. And let's just jump right into it with tenant isolation. If you've ever lived in a block of flats or in a college dorm, you understand the noisy neighbor problem. A single user or a single workload that's very chatty, that does a lot of I/O operations, can actually go and cause a negative effect on another unrelated process on the same server. Well, this is something of an issue, especially as a cloud provider, right? You're supposed to be guaranteeing a level of service. You're supposed to be guaranteeing that workloads do not change in performance depending upon who else is running on the server. And the challenge there is, how can you do that with today's flash, and how can you do that in a way that doesn't negatively impact flash for the general users? Now, latency control. This is kind of an interesting problem because it's a one-size-does-not-fit-all kind of issue. Every workload works best with a different latency profile, whether they like to get things done very quickly with outliers like I'm showing there, or whether they like to have all their latency, all the I/O operations complete in a very short amount of time, very short span of time. The key here is a challenge. You want to deliver that sort of I/O latency performance, that profile, to individual applications, and you want to be able to do it to multiple applications on the same server, and you want to do it with the same hardware, right? You don't want to go and have one server for one specific workload and a different type of server for another. It's really an untenable problem. So that's really a challenge that we hear a lot about. Data placement. With data placement, it's a little subtle, but the idea is that if you organize data on the flash memory in such a way that related data that has the same sort of useful lifetime, that is written at the same time, if you can put that in the same block of flash, you're going to increase your performance later on. You're going to minimize the background processing, the overhead, the kind of the wasted cycles, the wasted flash lifetime. Now, with that, there's no real way today in a lot of these interfaces of specifying that. So your application is kind of implicitly expressing this in the way it's writing, in the way you're optimizing it, but there's no guarantees. And finally, flash migration. So I said we've been around 35 years. We've been doing amazing stuff. Not just us, the entire storage industry. I've been in the industry 20 years now myself, and the things that we do, every year the flash is faster, you're getting more layers, you're getting denser flash, you're getting higher performance interfaces. Well, that's wonderful. You know, we're doing a great job of presenting it to you, the customer, to use it in your cloud, but getting it into the cloud sometimes is a challenge, right? Because you've done this optimization before. You've optimized for prior generations. You've gone and changed your code to meet the latency profiles that one type of flash was giving you. When you move to a different type of flash, those implicit assumptions, those implicit choices you've made are no longer valid, and your code is no longer optimized, and that costs you time. That makes it slower to roll out new flash technologies and makes it harder to get the flash economics into your data center and reduce your TCO. The solution really to these challenges, I'm going to say, is the same sort of solution that you've had in the rest of your data centers. Make it software defined. Your data center today, top to bottom, is all software defined. You get top of rack switch is running a network, right? It's a network operating system. You're doing software defined networking there. You've got NPUs and DPUs inside your server, and they're doing the packet process offload. At the bottom layer, you've got a software-defined storage stack that's taking your customer's data and holding it for them safely. Well, if you take all that software-defined logic, why don't you apply it to flash technology? And that's exactly what we've done. And by doing so, this is really cool. I mean, first of all, you get rid of the legacy bottleneck, the legacy assumptions. Hard drives are great, don't get me wrong, but they're not flash. They're not massively parallel. They are not purely digital. They are not really made in the same way. And if you make flash software defined, you can actually unlock all that potential of that flash technology. You can take it and you can engineer it, customize it, bend it into your will, make that match your needs as a cloud provider to give the best possible service. And how do you get software-defined flash? It's software-enabled flash. This is a new technology that we've been working on for several years here at KIOXIA. And what it is, it's custom cloud-optimized hardware with an open source software stack that runs in the host that lets your application developers, let your storage developers actually do this software definition of their needs in the flash. Basically, and this is really neat. I mean, it completely changes the way you think about flash. It's not just a block array. It's not just address A and B. It changes the relationship between the storage device, the SSD, and the host, your applications. And when you do that, you're able to unlock all of this potential. You can actually write your application and explicitly specify the needs that you were going for. You could explicitly access that parallelism. You can explicitly assign data locations, etc. Basically, with all of this, the net is you're going to increase the value of flash in your servers. You're going to do more with what you've got. You're going to make it more effective with this new type of technology. Now, what is it? It's a duo. It's a pair. There's an open source hardware. There's a cloud optimized hardware. Now, this is focused really on flash control and not the block stuff that all the other SSDs are doing. It's focused really on giving this the flash low-level control to the software stack, giving controls, knobs and hooks so that this open source software stack that's running inside each and every one of your applications can use to define things like data placement, define things like latency outcomes. Basically, you can explicitly set these requirements in code as opposed to implicitly. How does software-defined flash, software-enabled flash, how does this help? How does this help meet the challenges that we've got, that we've identified? Well, let's look at it. Tenant isolation. We've got some really neat features here. At a very first level, we have hardware isolation. Hardware isolation basically is going to take portions of your flash drives and assign them directly to applications. What's neat about this is this guarantees at the physical level that one application cannot interfere with the flash processing that another application is doing. They're on different virtual devices, which is what we call these domains, then they cannot affect each other. On top of that, we have a software level. This software level we call quality of service domains. And this provides a dynamic isolation. Basically, it's application controlled. At runtime, you can use your hypervisor, you can do your orchestration to do this. You can do it inside the application itself. The magic here is this gives you a much finer grained control over flash and the outcomes. How does that work with data placement? So applications now, with software-enabled flash technology, the API, the software stacks let you actually specify the data placement of all your writes at the right time. The key here is your application is the one that knows. It knows that this data is going to live for the life of this virtual machine, or it knows this data is going to live for the life of this web request. It's the best one to do this, to know this, and it can transfer that information directly down to the drive itself and make sure that the flash is properly aligned. You get the two benefits here, right? You've organized the data in flash. That means that you've got less background processing, which gives you the benefit of longer flash usable lifetime because you're not rewriting. You have lower, what we call write amplification. And you also have more performance because you don't have those background processes eating into the foreground operations. That's kind of a really cool double win there. Now with latency control, the one size doesn't fit all. The way software-enabled flash handles that is through software-controlled queuing modes. We have 3 different types. We have priority queues, where the highest priority always wins for IOs. We have a very fair round robin. And we have what's really cool. It's called die-time weighted fair queuing. And it's kind of a mouthful, but the key here is the application, the hypervisor, the orchestrator can identify a cost function for each IO, for each application. And the hardware will actually use that to guarantee the performance and the priorities at the flash level. What that buys you is this latency control. You're able to identify, able to explicitly request certain sites for profiles. And because of that, you get a much better user experience. And what's also really neat is, so I said applications or containers, right? But this can also even be on a per IO basis. So if you have, say, background processing, you're doing a database compaction or a garbage collection, right? Something that's low priority, you can actually specify that as you're doing the IO submitting. And it will not impact the performance of the front end. It will go and find the nice idle slots. The hardware will handle this. It's really cool. Now, migrating between flash technologies. The issue is really the implicit versus explicit. Before you were doing implicit operations, your software devs were pulling their hair out. They're going to be bald like me, trying to get the best performance out for a single technology, and then everything falls apart when you change the underlying tech. Here, when you're migrating, you've already specified explicitly what you're trying to do. And that is going to give you the advantage of time to market. It's going to make it faster to get new rollouts, and that's also probably going to help you with the economics. Right? We're great about making Flash and making Flash better each year. You get better flash economics, the faster you get it, that's better TCO operations overall, better total cost of operations overall. And one more thing is, as the great Columbo would say, it's the open source software technology stack, and I'm really proud of this. This is something that we just formed, that we just started last week. Software-enabled flash technology, everything I talked about now has been released to a Linux Foundation project called Software-Enabled Flash Project, and it's open source, and it's an open collaboration. Really, the key here is we want to have a community. We want the community to be able to work. We want flash vendors. We want SSD manufacturers, controller manufacturers, and most importantly, the service providers, the people that actually use this flash, to all be able to work together to make this the ideal, make this the best possible solution for your challenges. And it's available at softwareenabledflash.org. It's kind of a mouthful too, but I'll show it again later. And to sum it up, really, software-enabled flash is software-defined flash optimized for the cloud. With all of these features, the latency specifications, the queuing, the isolation, the data placement, and the easier migration, really it changes the way you can use flash. It increases the value of flash in your servers in the cloud. Now, we have the open source project, softwareenabledflash.org, has a lot more information. I'm giving you the 10,000 meter view, or 15, 20-minute talk. But if you go there, you can get white papers, you can get more in-depth technical videos that go into the nitty-gritty bits and actually talk about a lot of things that I've had to gloss over due to time. It also has links to our code, and most importantly, it has information on how you can get involved with the project, the Software-Enabled Flash project. So with that, I want to thank you all for your attention, and I'd like to thank the CloudFest team for the work they've done to get us all back in person. Thank you very much.
So first of all, this is fascinating. What's your booth number again?
We are booth C02.
Now, where is that in the hall?
So you go in, we're the second row on the left, all the way against the wall.
I'm going to stop by. I'm working all 3 days in here, but I'm going to look for a gap because I want to come over and see that technology. It looks fascinating.
Thank you, sir.
My pleasure. Thank you very much. Everyone, well, thank Earle.
Thank you all.